Hello, good morning, students. Today, another important topic is in the friction, that is, why pulling the land roller is preferred than pushing. Explain. First of all, we are discussing about the pushing the land roller. Say, this is the land roller. Okay. Now, pushing the land roller means this is the central point of the land roller, let us say. Now, if you push the land roller, that means the force will be acting towards the ground. That means here the force will be acting in this direction. So, this is the direction. In this direction, the force will be acting. This is the F force, which making an angle theta with the horizontal, you can say. That is theta. If it is theta, this is also theta angle. Now this F force can be resolved into two components. Okay, this F force will be resolved into two components. One is in this direction, another is in this direction. Okay, before going to discuss about this, if the land roller is present at that moment, means two forces will be acting. One is upward force, another is downward force. Upward force always normal reaction represented with the symbol of N. Downward force always will be weight, that is mg. Okay, W is equal to mg. Now in terms of matter, you can better to write like this. Consider a land roller, okay, pushed by the F force, which makes an angle theta with the horizontal. So this is also proportional angle theta. Here weight mg will be acting downwards and a normal reaction n will be acting in the upward direction. So here F force can be resolved into two components. One is horizontal nearby the theta, that is F cos theta. This is F cos theta. This downward force you can call as F sin theta. These are the two forces acting. Now at equilibrium condition, sum of the upward force is equal to sum of the downward forces. You better write in the simple manner. So at equilibrium, sum of upward forces is equal to sum of downward forces. So what are the upward forces here? So this is normal reaction, only upward force, normal reaction, that is N. What are the downward forces here? One is weight, another is F sin theta. So which is equal to F sin theta, or you can say mg weight plus F sin theta. Now from this you will get normal reaction N is equal to mg plus F sin theta. Now here rolling is there, that means you need a rolling friction. So we know that rolling frictional force, that is frictional force F R is equal to mu r into N. This is the formula for the frictional force. Let us substituting this N in place of N, mg plus F sin theta. So if you write here, so frictional force, rolling friction, which is equal to mu r into mg plus F sin theta. This is the, let it be the equation number 1. This is about the pushing. Now go for the pulling the land roller. See this one. Same thing here. This is the land roller. Generally, if it is here, means two forces will be acting on that. One is the upward force, another is the downward force. Here upward force is always normal reaction and the downward force is always weight mg. Same thing, right? You have to write here. Consider a land roller pulled by the force F. Now pulling the force. Let us say the land roller will be pulled by the force in this direction. This is in the upward direction. I am pulling in the upward direction. So making with the horizontal, it will making an angle theta with the horizontal. So we better to write in the thick letters. Okay. Now this is the pulling force F with the making an angle theta with the horizontal. Okay. Again, this theta can be resolved into again two components. One is horizontal component, another is vertical component. Here horizontal component as usual F cos theta, this vertical component as usual F sin theta. Okay, same thing I had right here. Consider the lawn roller pulled by the force F making an angle theta with the horizontal. Now mg downward direction, weight, normal reaction, n on the upward direction. Now the F force can be resolved into two components. What is F sin theta and that is F cos theta as shown in the figure. Same matter for pulling and pushing. Same matter. Matter is same up to this point. Okay, now for easy point of view. So again you can use at equilibrium. Same concept here. At equilibrium, sum of upward forces is equal to sum of downward forces as usual. So what are the upward forces here? One is normal reaction, another is F sin theta. What is the downward force here? mg only. So you can use upward forces, that is n plus F sin theta is equal to mg, that is weight, or simply you can write here n is equal to mg minus F sin theta. Keep in mind. Now we need the frictional force again. Say frictional force Fr, rolling, mu r into n as usual. So you can write Fr is equal to mu r into n, means mg minus F sin theta. Let it be equation number 2. So from these equations 1 and 2, what do you observe? One is minus, another is plus. That means here rolling friction is more. Friction is more for pushing, whereas for this pulling friction is less friction. That means from 1 and 2, what do you observe here? From 1 and 2, what do you observe? You see that frictional force is more in pushing than pulling. 1 and 2, frictional force is more in pushing than pulling. Friction more means it is very hard to pull. That's why pull is easier. Hence, pull is easier. Pulling is easier than pushing. Hence, you can write pulling lawn roller is easier than pushing. That's all. Thank you for watching. All the best for the exams.